Hey guys, how's it going today? So today we got a little bit different scenery. We're out here in the patio, got the Blackstone griddle warming up. Today we felt like some grilled cheese sandwiches, okay, which is a great lunch, and it's easy to make, and it also relates to chemistry. So coming up here this week, we're talking about stoichiometry, okay? I know it's a big word, but it's nothing to be scared of. It's just looking at ratios to figure out different things and compare things, okay? So stoichiometry is a lot like cooking or baking, okay? So today we're making grilled cheese sandwiches. So let's first see or write out the recipe for a grilled cheese sandwich, okay? So if you see here, we have a recipe for a grilled cheese sandwich, okay? So let's say you have some friends over and you want to make some grilled cheese sandwiches, but you go into the fridge and you see that you only have 5 pieces of cheese, and then you go into the bread box and you only have 10 slices of bread, okay? Now I'm sure you can figure out how many grilled cheese sandwiches you can make, okay? But we are trying to relate this to chemistry. So, and also I want you to see how this relates to kind of everyday life. So let's write some ratios for our ingredients to sandwiches. Okay, so if you take a look here, we have all the different ratios that we have for these sandwiches. So making a good grilled cheese sandwich, we don't want the griddle too hot, right? We want to put our, we got that nice sizzle going, okay? So as we're cooking our grilled cheese sandwich, so we need 2 slices of bread, 1 cheese for a good grilled cheese sandwich. And we'll put our cheese in the middle. And let those toast up a little bit. Hey, as I got a lawn crew on my street starting to cut their dang grass. So as these are cooking up, let's talk about those ratios some more. So if we look at this picture, this gives us all of our ingredients, okay? But if we take that picture and we rearrange it into our ratios, it makes it a little bit easier to see how many sandwiches we can make. Let's see if these are ready to be flipped. Not quite ready. Alright, let's turn up the heat a little bit. Alright, so while those beauties are finishing, okay, let's talk about putting the grilled cheese sandwich into an equation, okay? So to figure out how many grilled cheese sandwiches we can make, right, you should have figured out that we could, with our ingredients that we currently have, we can make 5 sandwiches. Right? However, let's put this into an equation that we can use. So if we have, if we start with the 5 slices of cheese, okay, then we get an equation something like this. Okay, and it equals 5 sandwiches. Okay, if we start with the 10 slices of bread and we put in the ratios, we get an equation something like this, which also equals 5 sandwiches. So in this case, it doesn't matter what we started with as long as we know what the ratios are, okay? And we can apply this to chemistry. Okay, we can apply this to chemical reactions because chemical reactions are the same as a recipe, okay? Just like grilled cheese. So stoichiometry really is as simple as making grilled cheese sandwiches. Alright, here we are back in the garage, okay? So here's another example, okay? My grilled cheese sandwich was delicious, by the way, okay? But here's another example of how we use stoichiometry or these unit conversions in kind of everyday life. So let's say you sign up for the bake sale. What's a bake sale? I don't know. You guys were probably saying, I barely knew how to make that grilled cheese you were talking about a minute ago, okay? But let's say you did sign up for a bake sale and you're responsible for bringing 100 cookies. Okay? So here we have a cookie recipe. 4 tablespoons of butter, 1/3 cup brown sugar, 1/3 cup white sugar, an egg, 1 cup flour, 1 teaspoon of baking soda. This gets you 20 cookies. Okay? So we can use these unit conversions to figure out how many or how much of this stuff we need. Right? So we need 100 cookies. Right? So if I start with 100 cookies, okay, how many batches of cookies do I need to make, right? So one batch yields 20 cookies, right? So keeping your units together on that angle so that they cancel out. So we're going to put cookies on the bottom. So for every 20 cookies, is one batch of cookies. Okay? So for every one, so every 20 cookies gives me one batch of cookies. Okay? So how many batches of cookies do I need to make for this bake sale? That's right, 5 batches. Okay? So now, when you go to the store, okay, you will know how much stuff you need to get. Because I use that 5 and I multiply it by all my ingredients. So for instance, if I want to know how much butter I need to pick up at the store, then I need to make 5 batches of cookies. Okay? And one batch, I need 4 tablespoons of butter. Okay? So that means I need to get 20 tablespoons of butter. Okay, so as you can see, you can figure out how many of each ingredient you need to pick up from the store. So that's just another example of how you can use these unit conversions and essentially stoichiometry as a way to relate it to everyday life. Alright, so the next task is we're going to start taking a look at how we can apply this to our chemistry stuff. Okay, so as we go through this, keep in mind that in the beginning of this, when I was talking about the grilled cheese sandwich and how this was like the grilled cheese sandwich, it really is. Okay, yes, the grilled cheese sandwich is a pretty simplified version of this, but if you take that in consideration and apply it to some of these things, you'll see that it really is just like making that grilled cheese sandwich. Okay, or using those unit conversions to see how many cookies that you need to, or how many batches of cookies you need to make in order to get 100 cookies. Okay? Alright, so you should have this out in front of you with you. Okay? And we're taking a look at how to do this in a chemical problem. Okay? Or chemical equation. So the chemical equation is the same as the grilled cheese recipe or the cookie recipe. Okay? You start with some ingredients and you get something at the end. Okay? A chemical reaction is the same thing. You start with reactants and then you get products. And we've already seen how those are written. Last week you did some balancing equations. So the reactions that we're going to see today are already balanced. However, if they aren't balanced, that is part of this process. But the ones that you're going to see today are already going to be balanced for you. Okay? Alright, so looking at the paper, it says a chemical equation shows the reactants, left side, products, right side, and a chemical reaction. A balanced equation shows, in terms of moles, how much of each substance is involved in the reaction. Stoichiometry is the study of relationships of quantities of substances in a chemical reaction. Okay, so we're looking at this chemical reaction. All right, so we're taking a look at this reaction here on our paper. All right, FeCl3 plus 3 NaOH gets us FeOH, 3, and then 3 NaCl. Okay, so what this is saying is that 1 mole of iron chloride and 3 moles of sodium hydroxide react together to make 1 mole of iron hydroxide plus 3 moles of sodium chloride. So that's what's needed in order to react completely. Okay? So sometimes we don't always have all of that. Sometimes we have a limiting reactant. So for instance, if we were making the grilled cheese again, if I said we had 11 pieces of bread instead of 10, we would have one piece of bread left over, right? Because we don't have another piece of bread to make a sandwich, and we didn't have another piece of cheese. Okay, so there are some limits to this, right? But if we have everything perfect, that's what we would get. Now we could have excess of one and then the other. Combustion reactions are like that. Whenever we burn something, we need the oxygen. Well, we have lots of oxygen in the atmosphere for it to burn. So we have what we call an excess of oxygen. All right, so the next thing it asks us to, so this balanced equation tells us what we just did. So the next thing I want you to look at is some of the possible ratios. And some of those are on the paper for you. So for every 3 moles of sodium hydroxide is equivalent to 1 mole of iron chloride. Or 1 mole of iron chloride is equivalent to 1 mole of iron hydroxide. And so basically what it's saying is we can make a ratio based on each of these different components in our equation. Okay? So 3 moles of this to 1 mole of this. 3 moles of this to 3 moles of that. Okay? And we only do that between 2 at a time. Okay? And that's something that's important to realize here. All right, so you recognize these as conversion factors. The first relates moles of the 2 reactants. The second and third relate one of the reactants to one of the products. So no matter how much of each reactant there is to start with, they will react only in the ratio of 1 mole of iron chloride to 3 mole of sodium hydroxide. If exactly 1 mole of iron chloride and 3 moles of sodium hydroxide are brought together, both reactants will be completely consumed. If 1 mole of iron chloride and 5 moles of sodium hydroxide are brought together, only 3 moles of the sodium hydroxide will react. 2 moles of sodium hydroxide will be left unreacted. Okay, so that's some of the stuff that we were just talking about. Like if we had the extra piece of bread, we would have an extra piece of bread. We couldn't make a sandwich with it because we didn't have enough stuff. And that's exactly what this paragraph is saying. So let's take a look at an example of how to do one of these problems. So we're going to be referencing this equation during this problem. And then at the end of this, I have 2 check for understanding equations. There's only 2 of them. Okay, and they're set up the exact same way, and there's a template at the bottom of the page to help you. Okay, but we're going to work through some of the individual steps here. All right, and it talks about the conversion sequence on your paper. So the conversion sequence, it says, so we start with grams of iron chloride. So the first step is to change that into moles of iron chloride. Then step B says take that answer, change it to moles of sodium hydroxide. And then step C, change it into grams of sodium hydroxide. Okay, so we're going to take a look at how to do those steps a little bit more in depth. Okay, so let's do these with me. So the first, so we want to know, according to this, is what mass of, where's that? Here. What mass of sodium hydroxide is needed to react completely with 10 grams of iron 3 chloride? So sodium hydroxide is your B, substance B. That's what you want to end up with. And iron chloride is your substance A. And that's important if you're going to take a look at the template that I have at the very last page for doing these problems. So again, sodium hydroxide would be substance B, and iron chloride would be substance A. All right. So we need to start with the first thing we need to do. So step A is to convert grams of iron chloride to moles of iron chloride. Now this is something you know how to do this calculation, right? We've done grams to moles, moles to grams. There's no particles today. Okay, so there's no moles to particles or anything like that today. Today we're just focusing on mass and moles. Okay. So if we start with 10 grams of the sodium chloride. Now I'm going to keep, when we start doing this stoichiometry stuff, sometimes it's important to keep the substance together because the substance changes in the middle of the problem. All right, I like to put it over 1. It's not necessary, but I like to put it over 1 because it helps keep, for me, it helps keep everything in line. Okay? All right, so then the next step. So I want to convert grams to moles. And again, remember, whatever units here, put it down here because I want it to cancel out. Okay, just like a math problem. And mole. So for every 1 mole of iron chloride is going to be the molar mass of iron chloride. Okay? So the molar mass, again, that's where we look at this and we add it up from the periodic table. So iron, 1 iron, and 3 chlorines. So we should get 162.3. Now, multiply everything on the top, divided by the bottom. So 10 times 1 is 10. 1 times 162.3 is 162.3. Then we divide those two. So basically what we're doing is we're dividing 10 by the 162.3. And we should get 0.061 mole. Okay, and this is mole of iron chloride. Okay, mole of iron chloride. So I'm just going to go ahead and box that in. Okay. All right. Step B. Now step B is we want to take mole of iron chloride and compare it to moles of sodium hydroxide, sodium hydroxide. Okay. So I'm going to take the answer here, 0.061 mole of iron chloride. Okay. Now, step B is the new step here. This is the stoichiometry step. You know how to do this, right? But now we're asking not to find something that's not of the same thing that we started with. We're asking it to find it of a new substance. That's why at the beginning I said this is substance A, this is substance B. So this is where we're going to use the mole ratio. Okay, and that mole ratio comes from the equation, right, with the coefficients. So I'm going to box this in real quick because this is kind of a special step. And I'm just going to label it as mole ratio. Okay, so again, sticking with the theme that I take this unit, which is moles of FeCl3, and I put it down here. And I want to find, ultimately I want to find mass of sodium hydroxide, but first we need to find moles of sodium hydroxide. So here is moles of sodium hydroxide up here. Now this is where I put the mole ratio from the equation. So for every 1 mole of iron chloride, it is to 3 moles of sodium hydroxide. Okay? So this is going to get, so this cancels. Okay? And it's going to get me moles of sodium hydroxide as my answer. Okay? So we should get 0.185 moles after we multiply that. And this is sodium hydroxide now. 0.185 moles of sodium hydroxide. So there's your step B. All right, step C. So this is where we take our moles of sodium hydroxide back to grams of sodium hydroxide. So again, this is another type of problem that you know how to do. Okay, so we had 0.185 moles of sodium hydroxide. Okay, so a mole of sodium hydroxide is the same as the molar mass of sodium hydroxide. Okay, so for every 1 mole of sodium hydroxide, it's the molar mass of sodium hydroxide. So again, it's these elements from the periodic table added up. Okay, this is something that we've done from the start of this whole process. Okay, so we should get about 40 grams for that. Okay, and I have some things written down just to speed up this process. So this is multiplication here. Okay, so 7.4 grams of sodium hydroxide. Okay. All right, so that's our final answer, right? Because we wanted to know, if you go back to what the question was what mass of sodium hydroxide is needed to react completely with 10 grams of iron oxide, or iron chloride? And that would be 7.4 grams of sodium hydroxide. And this is something that we could test in the lab. Okay, we could test that. And your next assignment this week is we're going to be back in the lab doing another investigation with this stoichiometry stuff. Okay, where we are going to be taking masses again and stuff. We've been doing a lot of mass measurements and looking at reactions lately. Okay, stoichiometry is used in industry, like whenever like fertilizer companies. Okay, they want to know how much fertilizer they can make from their starting points, their reactants. What's the most efficient way? Okay, this is what we call a theoretical yield. Okay, a theoretical number. We could do this reaction and we could compare it to what we actually get, and that's a little bit of something of how our lab's going to go for our second assignment this week. Now, you can do all of these steps all in one shot. Okay, you can most certainly do the A, B, C. Okay, but you can put them all in one line, and that's what that template is at the end at the bottom of the page underneath the 2 problems that I want you to work on your own here today. Okay, so again, putting it all together. Okay, all right, so we started with the 10 grams, right, of iron chloride. And again, I like to put this first one over 1. Don't have to. You could just leave it, okay? You guys know how that works in terms of math. I just like it because it keeps it on top. All right, so then this is where step A goes. Step A was that for every 1 mole of iron chloride, it was the molar mass of iron chloride. So all I'm doing here is putting A, B, and C together. Okay? So that was 162.3 for the mass of iron chloride. Then we put step B in there, that mole ratio. So for every 1 mole of iron chloride, we need 3 moles of sodium hydroxide. Okay, so there's step B. So here's step A. Here's step B. Okay, and now let's put step C in there. Okay, and that was for every 1 mole of sodium hydroxide, we put the molar mass of sodium hydroxide, which is 40 that we figured out. Okay, so there's step C. Okay, right, so moles of NaOH cancel moles of NaOH. Moles of FeCl3, cancel moles of FeCl3. Grams of FeCl3, cancel grams of FeCl3. What we're going to end up here, unit-wise, is grams of NaOH. Okay? So I'm going to go ahead and write that right now. Okay? And if you work this all out, 10 times 3 times 40, get an equals for that, then divide by 162.3, you should get real close to this. Might be a little bit, like that decimal might be a little off just because of the rounding that happens here versus losing some rounding in all the different steps, but it's not going to be a huge difference. I'm talking like 0.2 difference. Okay, so I'm just going to write this 7.4 here. Okay, but if you do it all 3 steps separately, or if you use the template and put everything in one step, then you should be getting similar answers there. Okay, so now the next part is I want you to check your understanding. Do those 2 problems. Make sure when you submit, you are checking your comments, because I am making comments for fixes. I am expecting fixes for these. You know, I've significantly reduced the amount of problems that I would normally give, so I'm looking for you guys to get it right. Okay, so keep that in mind as you're working through these, and if you want to keep up, try to get these done earlier rather than later in the week. Okay, and hopefully we're doing okay. And if you need help, don't be afraid to ask for help. Okay, I don't know if you're supposed to read the last week's weekly announcements, and I'll put it again in this week's announcements too. But I created a Google Voice account, and you can text that number, you can call that number. I'll have it on during normal school hours, a little bit longer, till like 4 o'clock maybe. But you can leave a voicemail, you can call, I can pick up. Okay, you can text. All right, it might be quicker than the Schoology messaging. The Schoology messaging seems to delay a little bit from when I see it and when I get back to you. Okay, so hopefully everything is still good, and we'll be in touch on the next assignment here. Okay, we'll be back to playing with some fire and stuff. Okay.